Machining internal gears on the shaper with a single tip tool. Yes, this seems surprising, but it's possible while not very convenient for us, as while this process was used on the MAG brand gear cutting machines, it was only worth being used for modules being 12 mm minimum. A giant one for us, as the tooth 8 is so 27 mm. But why not using this process as a challenge for cutting smaller modules? Here, a 24 teeth module 1.5 mm internal gear will be machined as shown on the picture. As we are working inside the board, this process is the negative of the one already described for cutting involute gears with a rounded edge parting off tool, as can be seen on the picture. But of course, in a bore, things are more complex. Remember that for an internal gear, the foot diameter is bigger than the head one. The gear dimensions were obtained from the free filengrene software. A link is given in the description to get this software. A positive profile shifting is necessary here on the wheel, as the teeth number of the wheel is small relative to the pinion teeth number. This small teeth number for the wheel was chosen as 2 passes are necessary for machining the teeth, so 48 for the whole wheel and some more for tooth thickness adjustment. In the previous process seen on the left of the picture, the tool was fed to the tooth 8 and then moved while cutting, the arrows showing the movements of the blank relative to the tool. The starting and stopping points could be exceeded with no problems, and 2 involute flanks were machined on 2 successive teeth, one on each side of the between teeth space. A link is given in the description for the video showing this process. This is not possible now. The 2 involute flanks must be machined separately, so the work must be made in 2 stages, and the stopping points must not be exceeded or the tool will dig in the gear rim. This is shown on the right side of the picture. The single tip tool machining the right tooth flank from the tooth head to the bottom. The arrows are showing the movements of the blank relative to the cutting tool. There is no relieving for the tool, so the clapper box locked. On the picture, the 3 between tooth spaces are the ones of the same tooth for 3 successive positions from the start to the end. The gear base circle DB rolling on the single point rack. The process detailed. First, the blank. The bore is machined to the head diameter DA and a shallow 0.5 mm recess machined on the tooth and on the foot diameter DF. This is to know when to stop the transverse throw of the shaper. When the tool tip reaches the foot diameter, an index is then drawn on the shaper's vertical slide to know when to stop the transverse self-act. Indexes are then drawn on the blank as seen on the photo to show the starting, finishing, and middle point of the teeth profiles on the head diameter bore. This dimension was obtained from a large-scale drawing obtained from a print screen of the filengrene software result as seen on picture. This WI dimension can also be measured directly on the computer's screen, as there is a graduated line to get the scale. The blank is turned in the spindle for the middle point index to be in a vertical plane, cutting the blank axis and locked on the spindle. The tool tip tilted to the right is then adjusted to just scratch the right index as seen on the photo, and then the right flanks of the tooth space is machined as seen on this video. All the right flanks of the 24 teeth are then machined the same way. The tool tip is then tilted to the left as seen on the photo for machining the left flanks, but we must before adjust the tooth thickness. For this, the tip is set to scratch the left index, but for a slightly narrow between tooth space and the first left flank machined as seen on this video. The blank is then indexed by half a turn for machining the opposite between tooth space left flank. It's now possible to take the between pins measure. For this measure, it's possible to modify the between tooth space thickness with the adjustable rod seen on this photo. For this, the filengrene software is invaluable, as it gives the between pins measure, but also the span measure WK, that of course can only be measured on an external gear, the negative of the internal one. Example for our job. The between pins measure to obtain is 34.4 mm and the span measure 16.2 mm. The actual between pins measure is 33.8 and on the raft wheel. By fiddling with the software, in fact just changing the X value for the wheel, it's possible to get the corresponding span measure, so 16.5 mm. So the thickness variation 0.2 mm, easy to take with the adjustable rod, as this measure is to be taken on the base circle circumference. It's now possible to cut the left flank on the 24 teeth. The gear set is now tested for free and silent running, as can be seen on this video. The running test it works quite well. Conclusion: this process works well, but it's difficult to manage due to the tiny between tooth space for small modules. Some more information. For cutting steel, it's worth relieving the tool during the backstroke, but with two more difficulties. Firstly, the tool must work in the down part of the blank for the clapper box to be used, and so the generation made in the opposite direction for the bicircle of the wheel to be rolling on the single tool tip path. This is possible by setting the variable rod downwards, as can be seen on the photo. Secondly, the relieving must be done in the tip direction, and so the clapper box oriented in this direction, as can be seen on the photo. If not, the tool will dig in the profile when relieved. Look at this photo showing the end of the left flank's cutting process for a 39 teeth Module 1 wheel. Thank you for watching.